Hi, good day. Today I'll be representing the course project for the IT 211, and this is for data communications and networking 1. Today I'll be discussing, or I'll be the topic that I'll be, or the group that I chose is the group 1, which is the network fundamentals, network types and topologies, and network models. So right now, first we will go to network fundamentals. So a computer network is a set of computers connected together for the purpose of sharing. It is a collection of computing devices that are connected in various ways in order to communicate using electronics, such as, for example, you are able to connected to a different devices. So that's what you call a computer network. So end devices here. This is actually in other terms hardware components. These are the computing device that interconnect, which has an IP address that is unique for every computing devices, such as laptops, personal computers, printers, workstations, smartphones, IP, cameras, and etc. So, those devices, uh, there's actually a unique IP address on each devices. Okay. So second one here is intermediary devices. These are the devices that we use in order for us, or in order for the both end devices to be connected, such as hubs, switches, and wireless access point. We do have here also the routers, communication servers, and modems, and security devices as well, which is the firewalls. So that's actually the device that we normally use for the networking. If we're actually in a networking stuff, so you were able to hear all those devices or equipments. So here are the examples of the intermediary devices. We have here a hub, switches, router, a modem, and this device. So yeah. Also, we have here a this is actually the representation of network devices and components. So as we can see here, once we saw these symbols, well, it will show that this is a router, this is a LAN switch, LAN hub, server, personal computer, laptop, firewall, IP phone, wireless access point, wireless router, one media, LAN media, wireless media. So we're gonna see those picture. We're able to identify the type of network. Okay. So these are the application that normally these are the application which is used in computer network, such as games, databases, emails, video conferencing, file transfer protocol. Okay, but when it comes to standalone application, well, of course, we're not actually using a computer network for that. Okay, so next we have here the network types and topologies. So, local area network. This is an individual network that usually span in a single geographical area, providing service and application to people within a common organizational structure, such as single business, campus, or region. Common LAN devices are switches, hubs, and routers. So we normally actually hear or see this local area network if you're actually um, purchasing a telco, or I mean your telco provider, or you were able to see that on your computers as well. Okay. And second one, we have here wide area network. This is a network connection between two or more LAN over potentially large geographical distance. Often, particular node on a LAN is set up to serve as a gateway to handle all communication between the LAN and other networks. Communication between networks is called internetworking. The internet is the best example of WAN. So we have here as well metropolitan area network. MAN usually interconnects a number of LANs using a high capacity backbone technologies such as fiber optical links, provides uplink services to WAN and the internet. A MAN's coverage can span between cities as well. Alright. We have here the basic, or I mean, the logical use of the internet. We have here the client server model. Servers have software installed that enables them to provide information and services like email or web page to other hosts on the network. Clients have software installed that enable them to request and display information obtained from the server. So this is actually, as you can see here, the clients are actually your end devices, and the internet is actually, as you can see, on the cloud form, and they can actually request an information coming from the server, right? So the next one what we have here is the network design and topology. A network topology design is the arrangement of computers in a network. So right now we'll be discussing the different types of topologies here and how it's composed in a local area network, or how they organize the switches, LANs, or I mean switches, the hubs, how they how they design it. Okay. First one that we have here is the bus topology. This is a network topology in which every computer and network device is connected to a single cable. Second is ring topology. This topology that forms a ring, such as a computer is connected to another computer with the last one connected to the first. Next, we have here star topology. This is a type of topology. All the computers are connected to a single hub through cable. So next, we have here the protocols, network protocols and communication. So what is protocols? Protocols are rules that governs communication. It is made up of a group of related protocols that are necessary to communicate via electronic means. Alright, and the next one here, we have your networking protocols. Describe processes such as the format or structure of the message, the process by which networking devices share information about the pathway with other networks, how and when error and system message are passed between the devices, and set up the termination of data transfer session. So the next one that we have here is HTTP, which is Hypertext Transfer Protocol. This one, it is a common protocol that governs interaction between web server and a web application. So as we notice here, we normally saw this HTTP every time that you browse to the internet. You are able to see HTTPS on the web address. So this is actually one of the protocols in order for you to interact between your devices to the web server, right? And this one also defines the content and formatting of the request and response between the client and server, where both the client and the web server software implemented the HTTP application. HTTP relies on the other protocol to govern how the message are transported between client and the server. Second one, we have here Transmission Control Protocol. Transport protocol handles the individual conversation between the servers and client, and not just web servers and web clients, but also the TCP segregates the HTTP message into smaller pieces called segments. It is also responsible for controlling the information exchange between the server and the client, such as the size of the data, the flow of control on how much is sent and received, and the reliability on which the sequence number are monitored in case of loss or missing something. Next one, we have here Internetwork Protocol, which is the IP. This one, it transferred the formatted segment from TCP and encapsulating them into packets and designated the appropriate source and destination addresses from the original sources of host to the final destination address of host. It is used by router in selecting the best path to the destination host. Next, we have your multiple protocols. The message received by the host usually contains multiple protocols plus the actual data, which the application header may or may not exist. So here's the definition of encapsulation and decapsulation. For the encapsulation, this is the process to hide or protect a process from the possibility of outside interference or misuse of the system while simplifying the use of the system itself. Also make one type of network data packets to other data types. In computer network, encapsulation is the process of taking data from one protocol and translating it to another protocol, so the data can continue across the network. Next one is decapsulation. This is the inverse of encapsulation process. Encapsulation is the process of wrapping the data, while the decapsulation process is the process of opening the packs. So the next one here is the network models. Protocols and reference model, the one that we talk about right now. And the protocol model, this is actually provides a model that is closely equivalent to the structure of a certain protocol, while reference model provides a common reference for maintaining consistency within all types of network protocols and services. It is not intended to be an implementation specification. So right now, here are some models that we'll be discussing. First is the OSI model, stands for Open System Interconnect. This is a system that breaks down network functions, and this is also the most popular type of inter-network reference model. And this has a 7 layers of when it comes to this OSI model. While TCP stands for Transmission Control Protocol or Internet Protocol, this has only 4 layers only. And this is also known as the DoD, which is Department of Defense model. And this is the protocol that is used internet in the internet. So yeah. So right now let's go ahead and go to the OSI model. So just like what I mentioned earlier, we have 7 layers on the or in the OSI model. So first we have here application layer. Second is presentation layer. Third is session layer, transport layer. We have here network layer, data link layer, and physical layer. So as we can see here, here are the functions of each layer here. As we can see here, the application layer, presentation, session, transport, network, data link, and physical. So as you can see here, on the right side, here are some functions or the functions of this layer. So next, we have here the TCP IP model. Okay, and this has a 4 layers only. First one is the application, second is transport, third is internet, and fourth is network access. Alright, so yeah, that's gonna be it for the part 1 of the course project. So the next one here, we will be answering these questions. Just a second here. There. Alright, there. Alright. Alright, so there. So here are the part 2 of the part 2 of the course project. So first, complete the table. This include individual, discuss, answer each one of them. So convert the network address to binary. And then convert the prefix length to subnet and vice versa. Okay, so right now we'll be identifying the we'll be getting first the prefix, subnet mask, gateway address, broadcast address, and the binary address on each and every one of these. So first, how do we get the prefix of this? Just a second here. Okay. Okay. Hold on. Okay. So now, in order for us to get this, right. Okay, 2, 2, 4. This one 2, 2, 4. 6. 28, 13, 7, 35. Oops. Mm-hmm. Alright. 7, 3.5, 1.5, and 0.5. Okay. So each and every one is 0, 0, 0, 0, 0, is equals to 1, is equals to 1. Right. So, 1, 2, 3, 4, 5. Okay. So, for this, that. This one, 7. So, we will be getting the broadcast address for this. Okay. Broadcast address. Channel 172 to 1.95 point 1.5. Number 3, we'll be getting the subnet mask. 5.255. The fourth one, gateway address is yes. Now we will be getting 4 plastic 35 255. And the next one here will be the same. 7 that's 6 and then 172 8 599 5.84 5 9 is 1101.01 and the last one is 5.36.72. Okay. So for the solution, I'm sorry, I actually use a pencil here or a scratch paper. So yeah, yeah, that's gonna be it for the course project for the IT 211 data communications. And goodbye and thank you.